Hi, in the last few sessions, we talked about the std logic data type, signed and unsigned data type, and also the integer data type in VSGL. Now, in this session, we are continuing with more supported data types by VSGL. We will start from the Boolean data type. VSGL offers this built-in data type specifically designed for representing conditional values. It has the core concepts of true and false, forming the foundation for decision making and conditional statements within your FPGA designs. Since it's an integral part of VSGL language, so you do not need to include any additional libraries to start using Boolean data type. Let's explore that how to declare Boolean signals in VSGL. Same like the other data types, here are two types of examples. First is uninitialized declaration. So syntax is signal, signal name, colon, boolean, semicolon. For example, signal, sig e, colon, boolean, semicolon. This example will create a signal which is named as sig e that can hold either true or false values, but with no initial values is assigned. Now second is declaration with the initialization. So syntax is signal, signal name, colon, boolean, colon equals to true or false. For example, signal sig b, colon, boolean, colon equals to true, semicolon. This example will declare a signal named as sigb and which will be assigned as initial value of true. You can also initialize it to false using colon equals to false. Now let's talk about the enumerated data types. Enumerated data types are the powerful features in VSGL that allows you to create the custom data types. You can use those custom data types for your specific needs because these data types can be more representable in your VSGL designs because you are creating them for some specific needs for your project. Enumerated data types allows you to define a set of named values that your data can hold. These named values called enumerations. This can help to make your code more readable and self-documenting. For example, that you are working with a traffic light system. So instead of using generic numerical values like 0 for red, 1 for yellow, 2 for green, you can create an enumerated data type which is named as traffic light with the clear enumerations like red, yellow, and green. And hence, this can significantly improve the code readability. Suppose you are reading them exactly like red or yellow or green. Instead, some numerical code words like 0 or 1 or 2. So you can feel the simplicity in such use cases. Okay, now let's see that how you can declare those enumerated data types in VSGL. So let's understand it with some example. So write type traffic light is bracket red comma yellow comma green bracket closed semicolon. So this statement here defines a new data type named as traffic light, and this traffic light is having three possible values. First is red, second is yellow, and third is green. Okay, once we define our custom data types as an enumerated data type, the next step is to use that as a signal type. This means that we need to declare some signal with this data type named as traffic light. So, like we have the other examples, this also can be declared with and without initialized value. So first example is declaring the signal without initializing the value. So the syntax is signal, signal name, colon, traffic light, semicolon. For example, signal, current state, colon, traffic light, semicolon. Here, the current state is the name that we chosen for our signal, and the traffic light is the enumerated data type which we have defined earlier. We can also declare the signal by initializing some values. For example, signal current state colon traffic light colon equals to red semicolon. Now this initializes the value red to the current state, which is one of the enumerations within our traffic light data type. You can also assign the values into the signal, just like you can assign the values in the other data types. For example, next state gets the value of green semicolon. This statement will assign the value green to the next state, which is one of the enumerations within our traffic data type. Enumerated data types are the valuable tool for creating clear and maintainable code for such use cases. While VSDL offers a high-level abstractions with the enumerated data types, it is important to understand that how these translate to the underlying FPGA hardwares. During the synthesis, these type of typical implementations uses flip-flops. Now the question is that how many number of flip-flops? So to encode three different states like we have here, red, yellow and green, we are needing minimum of two flip-flops. This is because that each flip-flop can store a single bit, either 0 or 1, and two bits can represent the four unique combinations, that is 2 to the power 2, that is equals to 4. Next important thing is encoding. For example, that state red is encoded as value 0, 0, and yellow is encoded with 0, 1, green is encoded with 1, 0, and 1, 1 is a known state here because we have only three values. As we have only defined three states in this data type, so assigning 1, 1 would result as an undefined behavior. Note that this is just an example. The exact implementation might vary depending on the synthesis tool. So here are some key points. Number one is that enumerated data type enhances the code readability, but they have an underlying hardware representation. N number of flip-flops are generally required for 2 to the power n enumerations. The specific encoding scheme might differ based on the synthesis tool and settings. Understanding this hardware representation can be beneficial when you are designing the complex VSGL code and optimizing the resource uses as we discussed earlier. Enumerated data types allows you to define your own custom data types by listing out all the possible values that they can take. For example, think of the std underscore logic data type in VSGL, which represents the different logical states like 0, 1, tri-state, high impedance, weak high, weak low, etc. So all of these states are all enumerated when the std underscore logic data type is declared. When you are declaring an unenumerated data type, you are essentially defining a set of named values that the data type can take on. The std underscore logic data type is defined in the std underscore logic underscore 1164 package, which is why you need to include this package to use std underscore logic in your programs. Similarly, you can create your own enumerated data types by listing out all the possible values inside it. And these data types can be used to define the signals, variables, and other data structures in your VSGL code. In the next session, we will be talking about the array data types and custom data types in VSGL. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.